Hi students, so I am going to start now structure of atom in chemistry. This is a 10th class syllabus. So what is atom is? So atom is a indivisible particle, means not divided into smallest particles. So according to Dalton's theory. So then atom is derived from Greek word, so that is A means not, so atomos means so divisible is, atom means divisible, not divisible or indivisible is, not divisible, indivisible means. Atom has several subatomic particles, atomic particles. So among these subatomic particles, the most important particles are fundamental particles. They are so most important particles are fundamental particles, fundamental particles. So what are they? So mainly three, they are electrons, protons and neutrons. So fundamental particles mainly three, they are electrons, protons and neutrons. They are mainly subatomic particles or called as so fundamental particles. So which are electrons, protons and neutrons. All atoms have same subatomic particle, same subatomic particles, same subatomic particles. For this one is answer is yes, because of every atom of element consists the electron, proton, neutron. So whatever the atom is taken, hydrogen, helium, lithium, beryllium, whatever the atom is taken, every atom of element consists the main fundamental particles are electron, proton and neutrons. Now do the same number of subatomic particles are same or not? So now coming to the all atoms, it is the S1 answer for this one, S1. So all atoms have same number of subatomic particles, same number of subatomic particles. For this answer, no. So why no? So this for this answer we can write down no, because of every element itself has different kinds of subatomic particles. For example, if you take the hydrogen as one proton and one electron, and neutron if you take the H11, so this is the isotope 1, so neutrons are 0 is. Means if you take the helium, subatomic particle like proton, 2 protons and 2 electrons. When compared to these elements, atom of elements, so helium has 2 protons, 2 electrons, hydrogen has 1 proton, 1 electron. So they are different from one and other. Do the all atoms have same number of subatomic particles? For this answer is no. So how can you explain this? So coming to this hydrogen and helium, these two are different atom of elements. So in hydrogen, 1 proton, 1 electron. In helium, 2 proton and 2 electrons. So these are different from this one. So hydrogen, different number of subatomic particle, and helium also different number of subatomic particle when compared to both each and another. Now we have to know how these subatomic particles like electrons, subatomic particles like electrons, protons like electrons, protons and neutrons, how they arranged in atom, how they distributed in an atom is. So if you want to know the distribution of electron, protons and neutron in an atom, we have to go know the spectrums. So what is mean by spectrum? So spectrum we can define as splitting of light, splitting of the light into various color bands, is known as dispersion. The splitting of the light into various color bands is known as dispersion. In dispersion, the various color bands is called as spectrums. So various color bands in dispersion is called as spectrum. So a rainbow, example for the continuous spectrum is. Example for the continuous spectrum is. So what is mean by continuous spectrum is? Continuous spectrum means in spectrum, so there is no, if you take the spectrum on photographic plate, so plate, there is no gaps. Here are no gaps between these lines. No gaps or so no distinct lines. No distinct lines. So where all are so continuous. One color is merged with the another color is like rainbow. So rainbow is continuous spectrum in which no gaps and no distinct lines on photographic plate. So means one color is merged with the another color is called as continuous spectrum. So now a rainbow has 7 colors. So which are violet, indigo, blue, green, yellow, orange, red. So violet, indigo, blue, green, yellow, orange and red. These colors do not separate from one another. all are merged together is. There is no distinct separation is. There is no gap between them is. So this is a continuous spectrum is. So violet to the red now. So generally common experiment, when you heated the iron rod from low temperature to the high temperature, what will happen is, so when we heated iron rod, so until the incandescent, then it produced the different colors, so at different temperatures. So first one we can observe this a red color. On heating of iron rod, we can identify the red color, then orange color, then yellow color, and blue color is. Finally, at a high temperature, we can find out the white color is. All frequencies. So all frequencies can be find out here is. At a very high temperature, is where we can find out the white color is. So all frequency can exist in white light, so which is appear at very high temperatures. So where in case of the red color, orange color, yellow and blue color is. So heating from red color to the blue color is. First it become red, then orange, yellow and final blue color is. So here is the red color frequency is very low, blue color frequency is very high. So where in case of red to blue, where blue color has shorter wavelength and larger energies, more energy, larger energy, or longer frequencies. Most important one is shorter wavelength and larger energy and longer frequencies. Where in case of red one, so shorter frequency and longer wavelength is longer wavelength means red color has the lowest energy, longer wavelength and shorter frequency, where in case of blue is, so shorter wavelength, longer frequency and larger energies. Suppose at high intensity can we find out the different colors at a time? So no, because of at one particular temperature one color exists. So at a high intensity one color appear and the remaining colors are not appear is because intensity overcome the other intensity of the other colors. Because of at a higher intensity one color is appear at high temperature, the remaining colors are not appear along with the one color is because of one color has more intensity when compared to the other color intensity which are not appear. Now coming to the wave nature of light. Wave nature of light. So before going to the wave nature of light, first we have to know the some important waves like sound waves, water waves. How do you generate the water waves? Suppose if you throw this stone into a still pond, then produce the ripples. Then it transported into water waves on the surface of the water is. So it requires to produce the water waves, it requires the medium is. Where in case of sound waves, when suppose if you take the drum, when we beat it, it produces the vibrations. From vibrations, then sound waves are produced. So then sound waves also require the medium is. Where in case of electromagnetic radiations, coming to this electromagnetic radiation, electromagnetic radiations. So what are electromagnetic radiations? When charged particle vibrated or oscillating or accelerating, it produces the electronic and magnetic fields which are travel in the form of the waves. When charged particle accelerated, then it produces the electric and magnetic field in the form of the waves. They are called as electromagnetic waves. Then the electromagnetic waves, when charged particles accelerated, you produces the electric and magnetic components and travel, the change in the strength in the travel in the form of waves, and transmitted in the form of the waves. They are called as electromagnetic radiations. So then these electric and magnetic fields are perpendicular to each other. Let us see. So this is if you consider the direction of propagation of wave. So electromagnetic wave is. So there are two components which are these electric and magnetic fields. So then if you take this one component oscillated vertically, transmitted vertically, the second component horizontally transmitted in the form of the waves. So this is the horizontal component, so this is the vertical component, So we can write down here is vertical component, and this one is horizontal component. So these two waves, electric and magnetic. So whereas the vertical component is taken as a electric field, and horizontal component taken as a magnetic field, magnetic field is. So these two are transmitted perpendicular to each other is. So this is the, so one is a horizontal. If you take this propagation of direction of the wave, one wave propagated so perpendicular to this one, the horizontal waves. The second one is vertical component propagated like this is. So these two are perpendicular to each other, and so right angle to the propagation of direction of the wave is. So these are these electromagnetic radiation. It has two component, vertical component, horizontal component. So vertical component taken as a electric field, horizontal component taken as a magnetic field is. So these two are perpendicular to each other. So one is a horizontal to the propagation of the direction of the wave. Second one is this vertical propagation of direction of this wave is. These two are right angle to this one, direction of propagation of wave is. So now coming to these properties of the electromagnetic radiations. So then what is mean by crest? What is mean by trough? What is mean by wavelength? What is mean by frequency? What is mean by velocities? What are their units? Let us study it. Now coming to these properties of electromagnetic radiations, so which are mainly so wavelength, frequency and velocities. Suppose if you take these electromagnetic radiation, they travel in even vacuum. They do not require any medium. So most important one is the electromagnetic radiations are travel in even vacuum. They do not require any medium like water waves and sound waves. And now coming to these properties of electromagnetic radiation, electromagnetic radiations. First one is wavelength. So now take this propagation of direction of wave. If you take the vertical component, so traveling like that or transmitted like that. So this height of the upward displacement. So height of the upward displacement is called as crest. So downward displacement from propagation of the direction and peak of the wave in downward displacement is called as trough. The downward displacement is called as trough, upward displacement is called as crest. So when you take the wavelength, we can define that the difference between the two successive crests or two successive troughs. Suppose if you take this one and take this one, is difference between two troughs is called as wavelength, and also we can take as this one is successive upward displacement crest and downward displacement is called as trough. We know that. So what is meant by wavelength and electromagnetic radiation? The distance between the two successive crests or two successive trough is called as wavelength. The distance between two successive two successive crests or two successive troughs. Wavelength units are so angstroms, meters, centimeters, nanometers, picometers. So then 1 angstrom is equal to 10 power minus 8 centimeter is equal to the 10 power minus 10 meters. 10 power minus 10 meters. So like that 1 nanometer is equal to 10 power minus 7 centimeters and 10, that is equal to 10 power minus 9 meters. 1 nanometer is equal to 10 power minus 7 centimeter, which is equal to 10 power minus 9 meters. Where in case of picometers, 1 picometer is equal to 10 power minus 12 meters, that is equal to 10 power minus 10 centimeters. So the relation between 1 angstrom and nanometers, so angstrom and nanometers, 1 angstrom is equal to 10 power minus 1 nanometer is. 1 angstrom is equal to 10 power minus 1 nanometer, or 1 nanometer is equal to 10 angstroms. 10 angstroms. 1 nanometer is equal to 10 angstroms. So symbol is lambda. Wavelength symbol is lambda. So Greek word indicated by this one is. Now coming to the other property of electromagnetic radiation is frequency. This is indicated by nu. This is a Greek word. You can write NUE, that is a nu. So how can you define the frequencies? The number of waves travel through a point by 1 second or per unit now. So the number of waves travel through a point in 1 second is in 1 second, or you can define also number of waves travel through a given point per 1 unit time is. Per unit time is called as frequency. Per unit time is called as frequency. For example, if you take this point to this point, so the number of waves travel through a point per unit time is called as frequencies. So then the relation between these wavelength and frequency are, so nu is equal to 1 by lambda. Nu is equal to 1 by lambda. Nu is equal to 1 by lambda. A lambda value increases, frequency is decreases. Means, so in case of the waves, the wavelength is increases. That means number of waves is decreases. From this point to this point per second per unit time. So as maximum lambda value, as distance between the two crusts increases or two troughs increases, nu value is decreases. The number of waves are less here is. So where in case of number of waves are maximum, number of waves are maximum through a given point. From this point wavelength is very less here is. the lambda value is very maximum, means so lambda value increases, frequency is decreases. So wherein is lambda value is less because of number of waves more per unit time travel maximum one is. That nu is equal to maximum is. So reciprocal to the each and other is. So as lambda value increases, between the wavelength is increases between the two crests, the number of waves are very less through a point per unit time. So where in case of this number of waves is maximum, so with wavelength lesser wavelength and frequency is maximum. So wavelength is less, the number of waves travel through a point per unit time is maximum, then frequency is maximum. Then wavelength is decreases. Wavelength is decreases. This so what are the units of the frequency? So here cycle per CPSS or second inverses. So second inverses or CPSS means cycle per second, number of cycle per 1 second is. And also in SI unit of frequency is hertz. SI units of frequency is hertz. So now some questions can arise what we have completed till now. So do the all atoms have the same number of subatomic particles? So second question is what is meant by spectrum? Now third question, in rainbow which color has highest frequency? Then fourth one, how do the electromagnetic radiations are produced? Then what are the units of wavelength and frequency in electromagnetic